I'm Linda Ness. I'm a structural engineer, director of NJV Consulting in Durban. We are a principally consulting engineering company doing structural, civil and facade engineering. So it was a really interesting one because we knew that it wasn't going to be defined by structure actually. We knew that it would be all about the cladding, which is, I guess, why we're here today. So we immediately phoned up the cladding guys and said, look, how are we going to do this? We're trying to clad a parabolic shape into the middle. How on earth do you do that with linear ribbed sheeting? We knew that we could sort of press it and mold it in some respect, but we knew it was going to be about the sheeting. So once we'd figured that out, we actually did a sheeting diagram. It was actually the first thing we did before we even thought about structure. And it was only after that we thought, okay, now how are we going to do this? And I mean, obviously we could only do it with steel. The spans were too long to do it with anything else. And the other important decision we made was to put that all in the same camp. So the sheeting and the steel all with one contractor. And so in answer to the question, the steel ended up being a series of radiating trusses, which on a parabolic plan could only be symmetrical about one orientation. So it was reasonably complex, but actually once we'd finalized the sheeting, it was all pretty easy. I guess the sheeting geometry was the first one, and because it's such a big parabolic shape, and the sheeting can only be, should we say, squashed, for want of a better word, to a certain extent. We had to keep on dropping the step of the sheet, dropping it when we found ourselves at the limit of what the sheeting could get to. We've got some clever minds in our office who sorted out all the geometry with the sheeting guys, and ZipTech was the choice, obviously. And once they'd sorted out the geometry, we found everything else fell into place pretty easily. A lot of the problems were overcome at shop detailing stage, as they can be these days with the kind of packages that we're using, like Tekla, etc. So a lot of the challenges are thought about before we actually get onto site. This particular job was particularly challenging because of time, which isn't so unusual these days, but it was actually an operating car showroom when we were erecting over the top. And it was, if I recall, during or just before the rainy season. So it was all squashed. Time, people, operating business below you, all of that stuff was quite complex. And we had excellent contractors. And the architect was willing to listen to the argument from cladding rather than architecture, which was really enlightening. It was fantastic to work with Hans in every way, including, probably most importantly, we couldn't have done it without steel. I think, steel sheeting, steel structure. If you think about what else we might have used, concrete slab, not really. We didn't have the time. Would have been more expensive, and we couldn't have done it over an operation like that. Timber, spans were too big. Probably not compatible with the sheeting arrangement that we had in terms of thermal, perhaps. So there was no other material we could have used. I suppose, me personally, it's actually the second time I've been involved in this project. So I personally designed the original structure, which also was with Impact Engineering. So sort of 25 years later, here we are again. So that was quite nice to be chosen again. And then just to pull it off with that kind of geometry, with a linear sheeting on a parabolic radiating arrangement, we're quite proud of that.